Using a 20 amp breaker on a number 14 wire circuit presents a significant fire hazard due to the potential for the wire to overheat. The maximum current capacity of a number 14 wire is 15 amps. When a 20 amp breaker is used on this wire, it allows more current to flow than the wire can safely handle. This causes the wire to overheat, which can damage the insulation and potentially lead to a short circuit or fire. Overheated wires can ignite nearby combustible materials such as wood, paper, or insulation, potentially leading to a devastating house fire. Damaged wires can create electrical hazards that can shock people or animals. Electrical fires can cause extensive damage to a home or business, including walls, ceilings, and furnishings. Electrical fires can spread quickly and cause serious injuries or even death. The consequences of using an oversized breaker on undersized wire can be very severe. It's not just a code violation, it's a life safety issue. Breakers are designed to protect the wire. If a breaker is rated higher than the wire's ampacity, the wire can overheat before the breaker trips. Think of it like this: the wire is the weakest link in the circuit. The breaker should be sized to protect that weakest link. If the wire is overloaded, it will get hot. The insulation will melt or burn, potentially causing a short circuit. This short circuit can then ignite nearby materials, leading to a fire. Even if a fire doesn't start, the overheated wire can still cause damage to the insulation and other components in the electrical system. This can lead to future problems and require costly repairs. One example of this hazard happening in a real-world situation is in an old house that was being renovated. The previous owner had installed several 20 amp breakers on number 14 wire circuits throughout the house. While running a power tool on one of these circuits, a burning smell was detected. Upon investigation, after shutting off the breaker, the number 14 wire had melted and started to smoke. If this wasn't caught in time, it could have ignited a fire. The solution is simple: replace the 20 amp breaker with a 15 amp breaker. This will ensure that the current flowing through the number 14 wire does not exceed its safe capacity. Always verify the wire gauge and breaker size match. If unsure, consult a qualified electrician. Remember, electrical safety is paramount, and it is better to be safe than sorry. Using the correct size breaker for the wire is a fundamental principle of electrical safety. It protects the wiring, the building, and the people inside. Ignoring this principle can have devastating consequences. Therefore, regular inspections of electrical panels and wiring are crucial, especially in older homes. Look for signs of overheating, such as discolored wires or melted insulation. If any problems are found, contact a licensed electrician immediately. Also, never attempt to repair electrical wiring unless qualified and experienced. Electricity is dangerous and can be deadly if not handled properly. The National Electrical Code, also known as the NEC, provides detailed guidelines for electrical installations. This code specifies the correct wire gauge and breaker size for different circuits. The NEC Table 310.15b16 provides ampacity ratings for different wire sizes based on their insulation type and temperature rating. For example, a number 14 copper wire with type THHN insulation has an ampacity of 15 amps when used in a residential application. When selecting a breaker, it's important to choose one that is rated to protect the wire but not so low that it trips unnecessarily. This is where the concept of overcurrent protection comes into play. Overcurrent protection devices, such as circuit breakers and fuses, are designed to trip or blow when the current exceeds the wire's ampacity. This prevents the wire from overheating and potentially causing a fire. The NEC allows for some exceptions to the general rule of matching breaker size to wire ampacity. For example, a 15 amp breaker can be used on a number 14 wire circuit even if the load is slightly higher than 15 amps, provided that the breaker is properly sized to protect the wire. However, these exceptions should be applied with caution and only by qualified electricians who understand the code requirements. In general, it's always best to err on the side of safety and use a breaker that is slightly smaller than the wire's ampacity. This will provide an extra margin of safety and prevent the wire from overheating. To further illustrate the importance of using the correct breaker size, consider what happens when a circuit is overloaded. An overload occurs when the current flowing through the circuit exceeds its rated capacity. This can happen when too many appliances or devices are plugged into the same circuit. When a circuit is overloaded, the wires start to heat up. The higher the current, the faster the wires heat up. If the breaker is sized correctly, it will trip before the wires get too hot and cause a fire. However, if the breaker is oversized, it will allow the wires to continue to heat up until they reach a dangerous temperature. This can cause the insulation to melt or burn, leading to a short circuit or fire. Another important consideration is the type of load connected to the circuit. Some loads, such as motors, can draw a large amount of current when they start up. This is known as inrush current. If the breaker is not sized correctly, it may trip when the motor starts, even if the running current is within the wire's ampacity. To prevent this, it's important to use a breaker that is specifically designed for motor circuits. These breakers are designed to handle the inrush current without tripping unnecessarily. In addition to using the correct breaker size, it's also important to use the correct type of wire. Different types of wire have different ampacity ratings. For example, a number 14 copper wire with type THHN insulation has a higher ampacity than a number 14 aluminum wire with type TW insulation. When selecting wire, it's important to choose one that is rated for the application and the environment. Also, be aware that the length of the wire run can also affect its ampacity. Longer wire runs have a higher resistance, which can cause the wire to heat up more. To compensate for this, it may be necessary to use a larger wire gauge for longer runs. The National Electrical Code provides guidelines for rating wire ampacity based on length. It's important to follow these guidelines to ensure that the wire is properly protected. Regular maintenance of electrical systems is also crucial for preventing fires and other hazards. This includes inspecting the wiring, breakers, and other components for signs of damage or wear. Any damaged or worn component should be replaced immediately. It's also important to keep the electrical panel clean and free of debris. Dust and dirt can accumulate on the breakers and other components, causing them to overheat. By following these simple safety precautions, the risk of electrical fires and other hazards can be significantly reduced. Electrical safety is a shared responsibility. It's important for everyone to be aware of the risks and to take steps to protect themselves and their families. The number 14 wire is typically rated for 15 amps according to the NEC. The purpose of the circuit breaker is to protect the wire from overcurrents that could cause it to overheat and potentially start a fire. If a 20 amp breaker is used on a number 14 wire, the breaker will not trip until the current exceeds 20 amps. This means that the wire can be subjected to currents between 15 amps and 20 amps, which can cause it to overheat and potentially start a fire. The overheating of the wire can cause the insulation to melt or break down, which can create a short circuit. A short circuit is a dangerous situation where the current bypasses the intended load and flows directly back to the source. This can cause a large amount of current to flow, which can quickly overheat the wires and start a fire. In addition to the fire hazard, using an oversized breaker can also create a shock hazard. If the insulation on the wire is damaged, it can expose the bare conductor. If someone comes into contact with the bare conductor, they could receive a dangerous electric shock. The severity of the shock will depend on the voltage of the circuit and the amount of current flowing through the body. In some cases, an electric shock can be fatal. Therefore, it is important to always use the correct size breaker for the wire. If you are not sure what size breaker to use, consult a qualified electrician. The consequences of using a 20 amp breaker on a number 14 wire circuit are that electrical fires can occur where overheated wires ignite nearby combustible materials, such as wood, paper, or insulation, potentially leading to a devastating house fire. Shock hazards can occur where damaged wires create electrical hazards that can shock people or animals. Property damage can happen where electrical fires can cause extensive damage to a home or business, including walls, ceilings, and furnishings, and injury or death could also happen as electrical fires can spread quickly and cause serious injuries or even death.